This video is about chi-squared GOF test. We already learned the chi-squared independence test. GOF test is a measure of how well a statistical model fit a set of observations. Chi-squared independence test checks whether two variables are associated to or independent of each other. For GOF test, HO will be the data fits certain distribution, like uniform distribution, binomial distribution, normal distribution, and so on. When we say the die is fair, means the data follows uniform distribution. H1 will be opposite to HO. The data doesn't fit certain distribution or certain pattern. You need to find the significance level alpha. And here is the rule. If p-value less than alpha, reject HO. The degrees of freedom in GOF test is n-1. N is the number of values. In calculator, we will enter the data into spreadsheet. The degrees of freedom for independence test R-1 times C-1, R rows and C columns. You need to enter the data into matrix in calculator. After you calculate p-value and chi-squared statistic, you can draw conclusions like this. If p-value less than alpha, enough evidence to reject HO, then rewrite H1 at certain significance level. If p-value greater than alpha, not enough evidence to reject HO, you need to rewrite HO at the certain significance level. If you use chi-squared statistic, you will compare it to critical value k. If chi-squared greater than critical value k, enough evidence to reject HO. Otherwise, not enough evidence to reject HO. You just need to remember this is a less than. Here is a greater than. Reject HO. Reject HO. Guided practice 1. Leo is investigating whether a 6-sided die is fair. He rolls the die 60 times and records the observed frequencies in the following table. Leon carries out a chi-square goodness of fit test at a 5% significance level, which means alpha equals 5% equals 0.05. A. Write down null and alternative hypothesis. HO. Go back check what is tested. The die is fair. Go to HO. HO. The die is fair. H1. The die is not fair. Write down the degrees of freedom. Don't count degrees of freedom for this frequency. For number on die 1, 2, 3, 4, 5, 6. So df equals 6 minus 1 equals 5. df equals 5. Write down the expected frequency of rolling a 1 based on the assumption HO is true, which means the die is fair. The die is fair means every single number on die has the same probability of showing up on the top. So expected frequency equals P times N. Probability is 1 over 6 times number of trials, N equals 60 equals 10. Since the die is fair, the expected frequency for each number will be the same. So for expected frequency, every single number has the same expected frequency. Find the p-value for the test. We will put observed frequency and expected frequency into spreadsheet in the calculator. Go to on 1, no, 4, spreadsheet, PQ. Type in the data. Column Q is expected frequency. Then click on menu 4 stat tests. 7 chi-squared GOF. Double click this right arrow button. Get P. Expected list. Right arrow button. Get Q. Degree of freedom 5. Then enter. Chi-squared equals 6.2. P-value equals 0.287. df equals 5. E. State the conclusion of the test. Give a reason for your answer. Here is the rule. Please reject HO. P stands for p-value. L means less than. Significance level alpha. Then reject HO. P-value is 0.287. Alpha is 0.05. .287 is greater than 0.05. So we cannot reject HO. Not enough evidence to reject HO, which means HO is true. So write down HO. HO is the die is fair at the 5% significance level.